Miss Robinson, your third grade math teacher for the year. And last week we started doing some geometry and we went over a lot of two-dimensional figures and quadrilaterals. Remember, a quadrilateral is just a two-dimensional figure that has four sides to it and four vertices or four angles. So let's see what we're going to do this week. I can classify and sort two and three-dimensional figures. So last week we focused in on just two-dimensional figures. We're going to finish what we were starting last week. We didn't get enough time to finish all our quadrilateral stuff. And then we're going to move on to some characteristics about three-dimensional figures. So let's go try that. Okay, so last week we were going over two-dimensional figures, specifically quadrilaterals. So we went over like the basic two-dimensional figures, circle, square, triangle. Then we went over all these quadrilaterals, rhombus, parallelogram, trapezoid. And then we just went on to some of the bigger figures as well as pentagon, hexagon, heptagon, octagon. We talked about how many sides they have and how many vertices they have. Now we're going to move on. We're going to look a little bit more at some of the stuff we went over. We went over some geometry, right? Some vocabulary. An attribute is like a characteristic. Congruent means the same or equal size. Polygon is just a two-dimensional figure with straight lines, and a quadrilateral is any two-dimensional figure or polygon with four straight lines and four vertices. Then we specifically talked about like what a quadrilateral could be. What are the different ones? We have a polygon, trapezoid, parallelogram, rectangle, rhombus, and square. And we learned that a square could be called any of the other ones except for a trapezoid because it is a polygon. It is a quadrilateral. It has two sets of parallel lines like a parallelogram. It has four right angles or four angles that are exactly the same like a rectangle. And it has four equal or congruent sides like a rhombus. So it's all of those put together into one. Now we're going to continue our quadrilaterals and just kind of talk about what is their defining characteristics. We talked about what they can be called, but we didn't really write down what they each are and what makes them a little different from each other. So first we're going to start with trapezoid. And a trapezoid is something that makes the trapezoid specific to it and different than the other parallelograms is that it only has one set of parallel lines. And when we say one set, that means two parallel lines to each other. If we had two sets, these sides would be, but these two don't. They're going to meet one day. I always spell parallel wrong, so I want to make sure I'm spelling it correctly for you guys. One set of parallel lines, or two parallel lines. A set is two, right? I have a set of shoes, a set of hands, a set of ears to listen. There we go. Now let's look over at parallelogram. So for a parallelogram, its defining characteristic is that it has two sets or four lines, four total of parallel lines. Has two sets of parallel lines, which means these two lines are parallel to each other, and these two lines. It doesn't have to be angled this way. It can be whatever way it wants, which means if a rectangle has parallel lines here and parallel lines here, it can also be considered a parallelogram. And same with a rhombus. It has two sets of parallel lines here and two sets right here. Not two sets. It has two sets total. It has two lines here that are parallel and two lines here. So that is why both of these can be considered parallelograms. So let's look at a rectangle specifically. We know it has two sets of parallel lines. It also has four right angles. Which is just right here. These angles right here, how they're all the same. Those are our four right angles. I'm not doing a great job of drawing this. There we go. And a rhombus has two sets of parallel lines, and all four sides are congruent or the same. All congruent or the same. And then a square can also be considered a rectangle because it has four right angles. A parallelogram because it has two sets of parallel lines. And a rhombus because all four sides, oh, I'm sorry guys, all four sides are the same. And so even though these are all individual characteristics of these three, a square is different because it has to have all of those in order to be a square. Two sets of parallel lines. Four right angles. And four congruent sides. So both of these can also be considered a square. But unfortunately, a rectangle is not always a square. A rhombus is not always a square. A parallelogram is not always a square. A square can always be these three. That's why the arrows are going towards what it can be. But the opposite way does not always work. Because this does not have four equal sides, right? This does not have four angles that are exactly the same. All right, so we're going to move on from quadrilaterals. This was just kind of finishing up what we were talking about last week. And now we're going to move on to some two-dimensional figures. We're going to start with a prism sort. And this is stuff that you guys have gone over a little bit in second grade. So it won't be as difficult as if you had just learned it. So I want to remind us, a prism is any figure So a prism is a figure, I'm sorry, I should say a three-dimensional figure that has two faces connected by rectangles. All right. And so we're going to kind of just see what are prisms and what are not. Prism or not. Let's look at this figure. Well, I see two faces connected by rectangles, yes? Yes, so this is a prism. What about this? Well, I see two triangles on the ends, but if we look at what connects the triangles, this is 1, 2, 3, 4 sides. They're connected by rectangles. So this is also a prism. It's just a triangular prism. What about this? This has two faces, but it's not connected by rectangles. It's just a round figure. This is not a prism. Look at this. Well, this only has one face, and it's in the shape of an ice cream cone. It does not have any rectangles connecting it. What about this? I see 1, 2, 3, 4, 5, 6. So that means I have two hexagons, and they're connected by these long, skinny rectangles. So that would be a prism. Let's look at two more. I see I have this shape. It looks like a ball. It's called a sphere. There's nothing connecting anything together. It's just one flat, or not one flat, one curved surface. So it's not a prism. Now here I have a bunch of triangles connecting together. I only have, but each one we look at, they don't have an opposite side to it, right? It's all going to a point from a triangle. This is called a pyramid. There can be this kind where it's put together by a triangles to making the point, or there's a rectangle or square at the bottom, and the triangles are up making to the point, and it's also a pyramid, but not a prism. I'm going to give you guys 1 minute to look at what we've done so far. If you want to draw an example of some of these, you absolutely may. Okay, so now I'm going to put these figures away. You've seen some of them. Now we're going to look at pictures of them and write out some of their characteristics. So here, from what we learned just now about prisms, we know they're connected by rectangles. And I see there's a bunch of rectangles connecting either two squares together or two rectangles together. So these would be rectangular prisms because there's rectangles connecting rectangles together. I'm going to get a little closer. And on these rectangular prisms, we're going to look at what we did last week, which is vertices and faces. But we're also going to look at edges. So last week when we were talking about lines, right? Straight lines or curved lines. This time we're going to still talk about vertices, which are when faces come to a point. But we're also going to look at these edges, right? Which is what's making each of the figures. And then these flat surfaces or faces. So for this one, I see there is one, two, three, 4, 5, 6, 7, 8 faces. I'm sorry, vertices. 8 vertices. Now we're going to count the edges. We have 1. Let me see that one. Let me do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these dotted lines are just showing on the other side of the figure. 11, 12. So we have 12 edges. And the last thing we're going to look at are faces. Faces, we can't really like color them because it'll be hard to tell. We kind of just have to kind of look at them, right? So we have this face 1, the other side 2, 3, 4. So basically what we could do is actually look at 1, 2, 3, 4, where all my fingers are. 5, and then on the other side 6. So there's 6 faces. And that goes for the same thing for this figure over here. We could count 1, 2, 3, 4, 5, 6 faces. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know it's not traced very nicely. 12 edges and 1, 2, 3, 4, 5, 6, 7, 8 vertices. So there's our rectangular prism. I'm going to give you 30 seconds to write anything that you didn't have a chance to, but I moved pretty slow for this one, so we should be good. Okay, so the next figure we're going to look at is this. Here's a picture of what it looks like in real life. Right. So this is a prism because it's connected by rectangles. But the type of prism is triangular because we have triangles being connected by prisms. So we're going to call this a triangular prism. Now let's count how many vertices and edges and faces we have. We have 1, 2, 3, 4, 5, 6. 6 vertices. Now let's count our edges. 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. And our faces, I'm just going to use this to count up. I have 1, 2, 3, and then 4 and 5 on the other side. So I have a total of 5 faces. I'm going to give you guys a minute to write this down. 30 seconds. 30 seconds should be enough. All right, our next one is right here, but we also have it right here, and this is what we call a cube. It could also be a rectangular prism because um, squares can also be identified as rectangles, and these squares are, but for a cube they have to all be square faces, right? So it can also be a prism, but we're going to write cube. And let's count our vertices. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 vertices. Now I'm going to trace my lines and count my edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. And then if we're counting our figure, you can look at this. We have 1, 2, 3, 4, 5, 6 faces. About 30 more seconds to write this stuff down as well. All right, I have a few more figures on the other side. So this top figure we see, it looks like a circle, but three-dimensional, right? It looks like it could be a soccer ball, a basketball, any kind of ball, baseball, golf ball. It's in the shape of like what we see our sports balls in. So this has no edges, no vertices, and really it only has one curved face or curved surface. This is called a sphere. It's spelled funny. Sphere. We have 0 vertices, 0 edges, and one curved surface. All right, our next figure is what we call a cone. This. Basically, it's a circle being brought to a point. And with this, we have, we're going to write cone. We have 0 vertices, one curved edge, which isn't the same thing as a flat edge. Then we have one curved surface and one face. One face, which is in the shape of a circle, and one curved surface. All right, we have one more left, and it's a pretty important one. It's called a cylinder. Even though we only have one of it on here, it's just an important one that we go over a lot in 3rd grade. All right, these are different forms of cylinders. They're two circles being connected together by a curved surface. We have 0 vertices, two curved edges, two faces, right? We have circles, and one curved edge. All right, let's go back to our objective. Okay, so we just went over, like I said at the beginning, a few quadrilateral characteristics, and we really focused in on some three-dimensional figures. We learned a lot about prisms. We learned a little bit about cones, spheres, cylinders, pyramids, all different types of figures. So let's look at our objective again. I can classify and sort two and three-dimensional figures. So we did classify them. We didn't get to sorting them, so next week we'll end up sorting some more, seeing the differences between the two. Thank you for joining this week. I can't wait to see you all next week. Bye!